Okay, let's take a look at parabolas. So you have dealt with parabolas in the past, right? But we mainly focused on just being able to graph a parabola, which is really important. But there's more aspects you need to know about parabolas if you're going to be, say, engineering something with a parabolic shape. Parabolas come up quite a bit because of the way that they can be used to reflect light or sound and different stuff like that. So it's more than just being able to graph the thing. If you're going to make a flashlight where the beam of light comes out straight, you have to be able to figure out where to put the light source inside of that little parabolic lens inside of the flashlight. Like listening devices, where you've seen this, there's like a parabolic shape and it'll pick up sound from a large area. Well, it bounces all that sound down to a single point. You need to know where to put the listening device in there in order to make that thing work. So we already know some about graphing parabolas. You've done this with, we've seen them in the form y equals ax squared plus bx plus c. That's our standard form. And then we have this vertex form. We've dealt with both of those before. But we're going to look at parabolas from a little bit different perspective here. So let's read this definition and then I'll make sense of it for you. A parabola is the set of all points in a plane that are equidistant from a fixed line called the directrix and a fixed point called the focus that is not on the line. So this picture tells us what we're talking about. You can see our parabola here. We've got this parabolic shape. We have this thing called the focus, that's the point, and then we have this line called the directrix. Okay, so any point on this parabola is the same distance from this point as it is from this line. So you can see right here the vertex is right in the middle between the focus and that directrix, right? But if you go over here, it's a little harder to see, but this distance from this point to the focus is the same as this point to the directrix, okay? And that focus is really important because that's generally where you're going to put, the listening device, the microphone, if you're doing if you're trying to do something that will pick up sound and amplify sound. If it's at the light source for a flashlight, that's where you're going to put the light source. If it's a telescope, that's where you're going to put the sensor that picks up the light. Or if it's, if you're looking with your eye, that's where you're going to put the ability to view it, is right there at that focus. Okay. So how do we deal with these then? Well, we basically come up with a new way of writing these, which makes it a little bit more convenient. Okay, so the standard form of the equation of a parabola with vertex at the origin is either y squared equals 4px or x squared equals 4py. Well, how do we know which one's which? Basically, you should look at the pictures over here. So you can see that when it's y squared equals 4px, we're dealing with a parabola that opens sideways. When we're dealing with x squared equals 4py, we're dealing with a parabola that opens either up or down. So vertically, right? It opens up and down. So what do? Well, let's say we're given the equation y squared equals 12x. Well, we have to write that in the form y squared equals 4px. So what you do is you basically just break down your 12 as 4 times p. So 12 is 4 times 3. So that tells us that our p is equal to 3. And notice up here in the picture, they tell us everything that p tells us. The focus is located at 0p. The directrix is y equals negative p. Right? And for this picture, we have another version of it. So once you can figure out what p is, you know a whole lot of information about your parabola. So down here in this problem, when we're given y squared equals 12x, and we go, oh, we need to write that as y squared equals 4px, that makes p 3, because the 12 breaks down as 4 times p, then p must be 3, because 4 times that thing equals 12. And then we can see over here in our picture, we can see, well, the vertex is at the origin. We're doing problems right now where the vertex is at the origin. And then the focus is at 3, 0. That's the 3 is from the p value. And we can see up here from our picture, the focus should be at p0. And it's at 3, 0 because p is 3. And our directrix is equal to negative 3 right here. Right? X equals negative 3. So once you figure out that p value, it kind of like gives away the whole game, right? Now what you do once you figure out that, if you're dealing with something where the vertex is not oriented at the origin, then we just use our transformations from, I think, chapter 1, where you just, remember we were shifting things left or right and then shifting things up and down. That's all you're going to do here. And they give you a little bit of a nice cheat sheet if you want to do that. Right, where is it? Here we go, transformation of parabolas. They give you on page 728 kind of a nice little summary that can help you keep it all straight if you start to get a little confused about, oh, I'm shifting left, I'm shifting right, I'm shifting up, I'm shifting down. This table on 728 will kind of help set you right with it, okay? And that's really all there is to these. You will sometimes, just like all the conics, you're sometimes going to have to use completing the square to get things in the right form, but you hopefully are comfortable with that completing the square process by now. And then just a couple pictures I want to show you so you can see why this is important. Parabolas come up sometimes in architecture, parts of bridges and stuff like that. You can see here we have a light source shooting the lights out. You can see here we have a light source where the light source is right at the focus, and because if you do that right at the focus, then when it hits the parabola, all the light ends up bouncing off and being parallel. That's how you can see these spotlights where the beam just stays straight for a really long time. I mean, eventually it diffuses because it's bouncing off air molecules and stuff, but the light starts off just kind of going in a straight manner, and it's the opposite for a telescope. All the light coming in that's parallel bounces off this and goes to the focus. So that's why you have to be able to figure out where that focus is if you're going to be designing things that involve a parabola.